Hi, my name is Erin East. I am a training specialist with Keysight Technologies. In this video, I am going to discuss the basic principles of noise power versus the bandwidth of a measurement and demonstrate how to set a bandwidth limit. The equation to find thermal noise power shows us that noise power and bandwidth are directly related. This simply means as our bandwidth is increased, our noise power is going to be increasing simultaneously. For this reason, bandwidth limit filters have been implemented into Keysight oscilloscopes. An example of an application of bandwidth limit filters is making low power measurements. The system you are testing may be rated for 3 MHz, so it would be ideal to make your measurement within that same bandwidth. However, if the oscilloscope that you're using has a bandwidth of 1 GHz, you are introducing broadband noise into your measurement, thus reducing the accuracy. In order to reduce the noise power, you enable the 20 MHz bandwidth limit filter. For more specific information about low power measurements, see page 4 of Keysight's application note on evaluating oscilloscopes for low power measurements by clicking the link below. As mentioned in the example, one of the benefits of using a bandwidth limit filter on your channel is that it will help improve the accuracy of your low power measurement. In this exercise, we will see how the accuracy of the variance of amplitude changes once a filter is applied. I will demonstrate this by using a very noisy sine wave, which can be found in the training signals on your Keysight oscilloscope. We can use our histogram function in order to view the variance of our amplitude. Using your finger, draw a zone on the peak of the sine wave, like this. Then select Histogram. In the sidebar, we can see the value of our amplitude variance here. Right now, I do not have a bandwidth limit set, and we can see that my variance is currently about 44.7 millivolts. Now I can turn my bandwidth limit on by going into my Channel 1 menu. Under the bandwidth limit soft key, we can turn on the 20 MHz bandwidth limit, which is applied using a low-pass filter within the instrument. If we take a look at our sidebar, we will see that our amplitude variance has decreased to about 42.5 millivolts. This 2 millivolt reduction in noise power may look small on this 2 volt peak-to-peak signal we're using right now, but when working with smaller amplitude signals, such as 100 millivolts peak-to-peak, a 2 millivolt peak-to-peak reduction in the noise power is a 2% improvement in the accuracy of the amplitude measurement, which is very significant. If you have any other questions regarding noise power versus bandwidth, or how to set a bandwidth limit, please contact your local Keysight representative.